Welcome everybody to the Iliad Webinar Series. Today we are going to introduce the Ocean Information Model. We are very excited. This is brand new and you will get more detail about it. You will also learn more about how you can potentially contribute to the further development of it. So that's the program today. We have with us the experts that have been working on this. My name is Bente Lilja Bye. I will lead you through this webinar as usual. And as usual, this is recorded. You will get the presentations afterwards. And you will be strongly encouraged to engage in this webinar. We have a long time. We have put aside a good time for discussion. And we also have some polls that I would appreciate very much, or we would appreciate very much if you can contribute to. As usual, this will be published sometime during the presentations of each of the presenters. I will start by introducing you to the Iliad project and to the program, and then we can start. It would be great to know where you come from, by the way, so write your name and your institution or your field in the chat while I'm starting my my presentation. So I will start. Yes, so today the program is as follows. I will introduce you to the Iliad project and what we are doing, the digital twins of the ocean. Then Raul Palma will introduce you to the ocean information model itself. Then the use of standards and OGC standards will be explained by Rob Atkinson from OGC. And then we are also going to talk about the further process with this ocean information model, and Piotr Zaborowski from OGC will do that. So my name is Bente Lilja Bye. I am one of the partners of the Iliad project. I have a background from many years of working with ocean related subjects such as sea level rise, etc., tsunami warning. Currently, I am the innovation manager in Iliad, and I'm also doing a lot of engagement and capacity development there. I'm very passionate about making data interoperable and also open. So what is a digital twin of the ocean? The digital twin of the ocean simply provides a virtual environment that represents a reality, the reality that is complex, and we want to run models, predictive management scenarios, etc., on this digital twin. The innovative system that we are building combines many different sectors, sensors and models, and digital infrastructures. So, appreciating the fact that the ocean is very vast, and complex. It consists of geophysical, biological, and numerous interactions between these components, and also interactions with the human activity. And to reflect this complexity, the European twin, digital twin of the ocean is actually consisting of several contributions from several communities in Europe. And this ecosystem of contributions, both prior to the Iliad project and also at the same time, such as the Edito Lab and Edito Infra, that you might have heard of. It's sort of the core, the Edito Intra is the core digital twin, you might say. But there are so many other activities and projects, both in under the European Union programs, but also in the national programs. So, and all of this we want to combine, and that's why Iliad is very much about engaging the partnerships of the Iliad consortium, but also others around us, both in Europe, in Africa, in the Middle East, because that's where Iliad is represented, but also since the ocean is one, we are interested in working with others. So Iliad in a seashell, we are enabling an ecosystem of interoperable digital twins. We are using existing resources, as I said, but we are also providing new resources. We have additional sensors, we are developing tools, etc. What we want to do is to make this available for reuse, both by other thematic areas or other locations. And in order to do that, we have to have a marketplace. So we are establishing a marketplace where you can find components and combine those components of the digital twins in your application, in your new twin, if you like. And of course, these twins that we are developing are providing solutions to societal challenges that we are facing. We are talking about multiple twins. So we have thematic twins, and they are located in different geographical areas. So the thematic twins are addressing, for instance, you see here a number of the areas, the thematic areas. So ranging from oil spill to aquaculture to fisheries to renewable energy and so on. So we are covering many different thematic areas, and now you probably understand why reusing components of it is very smart economically, and also saving the planet actually by using less resources. So, and so Iliad is a partnership, and it's part of a regional and global dynamic ecosystem that is working closely with other projects and initiatives, as I said, and to ensure the alignment, and this is very relevant for the topic of today, to alignment by using similar standards, APIs, best practices, etc. So this is the starting point, very short. We are 56 partners. The total budget is close to 19 million euros, so it's a major investment. And we are planning to work on this for 3 years, starting in February 2022. So with that, I would like to introduce to you the first speaker, the one who has, we are very delighted that you are here, Raul, to talk about the ocean information models. You have been working about information models in other contexts as well, I know. And you are working at the Poznan Supercomputing and Networking Facility in Poland. And you have lots of experience from data modeling, knowledge representation, data integration, and so on. I'll leave it at that. I'm sure we are excited to hear what you are about to tell us. So the floor is yours, Raul.
Thank you very much, Bente. Hello, everyone. I will, gladly start my presentation. Let me see if I can. I don't see my share button. Do I have the share button, Bente? Yeah, I have it. Okay, perfect. Okay, so. Can you see my presentation in full mode? Presentation mode?
Yes, we can, Raul.
Okay, great. So I will talk about the ocean information model and also a little bit about the related tools that are giving the support for the ocean information model. So I will briefly start with a bit of the context of this. So basically in Iliad, one of the things, of course, that we are dealing is trying to address the different challenges regarding interoperability. As you probably have some knowledge about this, there are different types of levels or layers of interoperability that range from the basic ones, communication, enabling the communication between different systems, then to some kind of intermediate communication where you have some kind of metadata or common formats to representation of the data. Then you have some more syntactic interoperability where you have some kind of structure APIs, some data models, and at the end you have at the higher level what we call the full semantic interoperability, and this is where the ocean information model comes into place. Of course, this is aligned as well with the, all of these initiatives related to data spaces, which are now very common and very prominent in the European Commission. So going into the semantic interoperability, this ensured the common understanding of the meaning of the exchange content. And it involves different pieces. It involves the common data models, involves interoperability mechanisms, and it also involves the interfaces, standard interfaces to access the data. So there are, of course, several standard initiatives that have proposed models for various domains, including the ocean, that are relevant to the ocean domain, which are used for different purposes and objectives. So more recently, what we are trying to do instead of creating new models is actually to leverage what is existing there, to reuse as much as possible what is there, align with the standard, and this is what the ocean information is trying to achieve. So with that introduction, the ocean information model is basically bringing the basis for a common ocean data space, enabling the interoperability of different systems, and the analysis that is of the data that is produced by those systems in an integrated way. So in a nutshell, the OIM is designed following a modular approach in a layer architecture, taking into account, of course, the data requirements in Iliad. It's realized as a suite of ontologies. This is like the formal representation of the model, but it also includes several semantic related artifacts like JSON LD context, which facilitates the adoption by developers, and is published via some persistent identifiers that are accessible and resolvable. Of course, as I said before, it's implemented in line with best practices, reusing standards and well-scoped models, and includes alignments with different other models that might be relevant to the ocean information model and the ocean domain in general, enabling the interoperability and integration of existing data. So this is a very high-level view of the model. You can see there, we have, of course, a GitHub repository where you can find the model itself, and this is the persistent URI of the model, so you can reference this, and you will get access to that. So going shortly with into these layers, let me go first with the cross-domain layer. So the cross-domain layer is like providing this kind of generic model that is reused by different models, relevant models or related models. So this, as it is, basically defines concepts and terms that are generical and that are applicable to various domains. And in doing so, we avoid conflicts or redundant definitions of the same concepts. That's the main idea here. And of course, it provides like the higher level basis of interoperability with the information system and tooling that are aligned with this model. So even if you are talking about multiple models, multiple domains, we are trying to align them into some kind of common layer framework, but this is like the cross-domain layer that will allow us to integrate data coming even from other domains that might be relevant. So as it says, it's reusing different vocabulary. So this includes, for example, the W3C, OWL ontology related to concepts, temporal concepts and properties, the OGC geospatial vocabulary that defines all these properties for geographical information. Also, another recommendation from OGC and W3C, which is the SOSA SSN, which allows you to represent sensor data, actuator data. So this is one of the core elements of the model. QDT regarding units of measurements, for example. Also, we have the RDF data cube vocabulary to represent statistical data. And obviously, you have some common well-used vocabulary like SCOS, FOAF, schema.org that are also connected into this kind of common layer. And also, we are having some alignment with the ISO geographical technology standards as well. So that's more or less the more important or relevant elements of this cross-domain layer. And this is how it looks from the top. So the cross-domain layer can be connected or aligned to several higher core meta models that we call them, like you saw in the previous slide. So the cross meta model, these core meta models, in Iliad, for example, we have some connections made to the NGS ILD that is also very common in the IoT world. It's coming from the firework community as well, which allows you to do this kind of representation of graphs and linked data. So this kind of conversion between graphs data and property graphs data and linked data. But obviously we can connect and align to other meta models. Now going into the domain layer, like the ocean layer, in Iliad in particular, we were interested in these models that we have identified. First of all, Darwin Core, which is an extension of Dublin Core for biodiversity, and includes, of course, also several extensions, including marine biogeography, and also the Humboldt extension, which includes some terms for the inventory of data to be shared, reused, compared, and integrated with other data sources of biodiversity. Apart from that, we have the SAREF, which is also very well-known model and set of standard, because this is a IFTF standard, which includes recurring concepts in smart application domains, and of course, the main relationship between them. And we also have connections and align with the smart data model. This is also coming from the FIWARE domain, which includes several data models for digital twins and data spaces to allow data interchange between organizations. And finally, we also integrated in the domain layer the climate and forecast. These are defining generic features intending to use into climate and forecast data in the atmosphere, surface, and ocean domains. And then, of course, we define some alignments with existing vocabularies. Basically, this includes the WORM. This is the World Register of Marine Species. Right? This is very important in Iliad. We also have the properties and variables from the climate and forecast related to ocean and sea futures. And agrobot, which is mostly known in the agricultural domain, but also includes relevant concepts related to fishery that are relevant for Iliad. Now, regarding the metadata layer, the metadata layer is based on standards like DCAT, the IDS information model. IDS means like the integrated data spaces information models, and the DQV, which is an extension of DCAT, which additional properties for expressing the quality of a data set. So this is in the representation here is how these are integrated into the OIM. So you can see how all of these different elements from IDSA, DCAT, and DQV are connected, of course. So what are the benefits of having this modular approach? Basically, this is enabling us to facilitate interoperability with existing models, because we can establish interoperability at the module level. We are also having easy alignment with other models by module, instead of like having like a monolithic, huge vocabulary that is very difficult to understand and read. And of course, the extension is also much simpler, because you can add modules as needed to the ocean information model. Of course, the maintenance and alignment with other cross-domain ontologies is simplified by this modular approach. So it's important here is that you could contribute to the ocean information model, with this modular approach, enabling this easy collaboration. All of these models and modules from the ocean information model are going to be in the OGC Rainbow server. You will hear a little bit more of that from our colleagues, Rob and Piotr. But basically, this is a web accessible source of information about things that allows you to see the definition of terms in a web accessible form. And you can also get different representations of the models from there. So once we have the model, of course, we need how to use this model. And this is where the pipelines for data harmonization and integration comes into play. Basically, as you can see here in the diagram, we have multiple data sources that are going through a process of data harmonization. I mean, pre-processing, enrichment, mapping specification, RDF generation, post-processing, storage, data linking, and finally publication. All of this process is what we call the linked data pipeline. And this main source here is the ocean information model, which provides the underlying model, how to represent the data in a harmonized way. Once the data is integrated and harmonized, you can have multiple toolings and applications to analyze the data that is integrated. So you can really leverage the full value of the data, because all the data will be accessible in an integrated way. So there is already some tooling about this. These are the data integration and preparation pipelines that is available for you to use it. It's open and you can define easily your pipelines for data harmonization and integration. And once you have all of these, the next step is to access the data. So to access the data, we also in Iliad try to advocate in the use of standard APIs, and this is where the OGC as well comes into play because it defines several standard APIs like sensor things API, futures API, coverage API, which allows some standard access to the integrated data. So once this is done, you have, of course, multiple interfaces to access the data. Of course, you have the possibility to use queries in a semantic way. That means SPARQL queries. You have faceted interfaces, custom REST API, standard APIs, web client applications, and so on. And to give you an example, in Iliad, we have been working with different pilots. This is one pilot that is coming from the jellyfish of data observations. That includes, of course, geospatial coordinates where they identify jellyfishes in the shores. And going through all of this process, at the end of the process, we get some sensor things API representation of this and access to this data. So basically, you have here the original source of data. This is coming like CSV files, which is then pre-processed, then is going through the pipeline of data harmonization and integration, and at the end, we have the possibility to generate automatically also the sensor things API that allows access to this data in a standard way. And finally, of course, there are other interfaces to visualize the data. So like, maps, faceted browsers, statistical forms, and so on. But all of this is facilitated and, leveraging the fact that we have data that is in a standard form and integrated. And with that is, I hope, like a short overview of the model. Of course, we are happy to have your opinions, feedback, and contributions.
Thank you very much, Raul. It's not an easy task to present all that technology in such a short way, so you did well. And I just want to say to the audience here that this is a lot to take in if you haven't been deeply involved in it, but I hope that you got a sense of what it's about. And I asked, there's a poll, and I'm asking you simply to consider if this is something that will be useful for you. And then, of course, we will go into more detail gradually, and this is not something that you can jump on immediately if you're not deeply involved in the development. But I'm sure there are some of you that this would be able to contribute to this. So I will share with you the results of the first of the poll, by the way. So, and we can use this for the discussion in the discussions session afterwards. So now you should see, I asked, is the ocean information model useful for you? And you see that most of you have said yes, which is a good thing. And then interestingly, and this is where we might be able to help, there are 17% of you are saying, I'm not sure. So we hope that you will be able to be sure during this webinar and maybe afterwards. So thank you for participating in these polls, and we will be able to answer questions and discuss after the rest of the presentation. So thank you very much for participating in this. And thank you also for providing information about where you come from and your names, etc. We want to have a community around these issues. So the next coming up is, I will share my screen again, is Rob Atkinson. Let me see, I will show you Rob before he shows himself. So Rob is responsible for establishing and implementing best practices for OGC publications of semantic resources, and manage also OGC Rainbow on behalf of OGC. Now, Rob has a background from computer science, and we are thanking you, Rob, for waking up in the middle of the night because you are in Australia. and you have a background from the Wollongong University in Australia. So thank you very much. You have been, so Rob is a senior experienced developer of standards and are passionate about that. I know you are, Rob. So the floor is yours.
Okay, let me see if I can share a screen, and with a bit of luck, it'll choose that one. So have my screen sharing now?
Yes.
Okay, so in 10 minutes, I can't cover very much. So I'm going to try to provide a very high-level overview of the relationship between the OEM and APIs and the OGC APIs as an option in particular. If time permits later, I can demonstrate some of the specification and sort of testing environments, but I'm going to start off by providing a high-level overview of how the ocean information model can get implemented in practice. So I'm actually going to start off with the fairly well-known FAIR principles, and what this really means in the context of a digital twin or marketplace environment. So fair, findable, accessible, interoperable, reusable is a very much a common sense sort of thing. But I actually want to start from reusability. Most people think of it starting from the findability and cataloging, which is fine, but the purposes of any resources is to be effectively reused where it's needed. And we actually need to work a little bit backwards from that. So reusability is where things like standard APIs, but also things being stable and persistent and having well-known licenses, all these things make it possible to reuse a resource, and then making it interoperable reduces the cost. And the semantic interoperability is an enabler that reduces the cost of understanding that data and translating it into the form you need it. Accessibility is where the APIs obviously come in. They reduce the cost of accessing the data, make it easier to do that. Again, reducing cost and time. And findable is basically about which parts of that metadata is surfaced up to your various discovery agents. So Raul mentioned a number of different standards, and some of them are for describing the structure of data. Some of them are describing very high level, sort of cataloging approaches. Some of them are very low level detail, like units of measure in the room. So the modularity of the oceans information model actually matches fairly well against the fact that these different concerns are live and need to be addressed systematically. And the other thing which is often missed is the sort of final phase, which is ultimately you need to evaluate this metadata to make a decision whether you're going to use it or not. And that's why it's really, really important that you can dive deeper into it to get more information. Raul mentioned linked data, and I think that's a classic example. So we want the ocean information model to support metadata that allows us to discover things, but also keep diving deeper into understanding what the pieces of the information mean, and which data might serve our purposes. So if we look at the relationship between the ocean information model and OGC APIs, APIs provide documented access methods, and OGC basically standardizes these APIs. I mean, it's not the only thing we do. We also standardize information models. For example, I'm a co-author on the SOSA standard that Raul mentioned, and also working on geospatial profiles of GCAT and RDF data cube and things like that. But we're best known for our standardization of APIs. And you have these reusable information models and schemas, which are at this very, very generic level, really around things like collections of features or coverages, distributions of data. And these are designed to allow us to have tools to serve data and to consume it. So it's really, the APIs are really largely the audience's software. It's not really about how you use those in terms of the content you deliver. And that's where OAM comes in. The OAM basically provides the interoperability layer for describing the content that you'll deliver through these typical APIs. And so one of the challenges that's faced is that the way APIs are connected to data models has always been somewhat ad hoc. There hasn't been a lot of standards for that aspect in terms of how to do it. And that's one of the areas where we've been specifically working on in terms of Iliad, in terms of understanding how to make that stable and scalable and sustainable and transparent. And the findability is partly dealt with by understanding that the descriptions of data and their services and the search function will be reusing the same concepts, which I'll try to explain in a little bit more detail. So one of the first things is that when we have data access APIs, they have data payloads which are structured according to the type of data. So people have ways of looking at and managing data which suits their particular needs. If I have huge amounts of data, I might put into a data cube. If I have a small amount, I might put into a spreadsheet. Now, these things affect the way we do things. If I have a time series data, I might use one approach. If I have a whole range of objects with rich metadata and histories, I might use collections of features. If I'm particularly interested in the geometry of those, then we get into these sort of geospatial features. There's also the OGC standards and other things which have been out there that have come out of communities of practice that have been widely adopted, typically by open source software and tools, things like NetCDF and so forth. So APIs have these native container structures and natural operations that work on the data dimensions. Systems, when they implement these, have specific needs, but as Bente mentioned, it's a system of systems. There are going to be systems out there that we don't have control over, we want to incorporate. And we want to understand how they relate to our own application domains. So we want to be able to also look at how we map existing systems to OAM, not just the OGC APIs or like Iliad defined ones. So take-home message here is that there's no single fixed API we're going to say you must use this. And we accept that APIs themselves will sometimes change over time. The Open API specification, version 1 is a version 3.1 on the table. We expect these things to change. But the underlying data is probably not going to change so much. And we want to be able to understand and identify what that data is, regardless of which API. So moving along from what that means, again, it's just reinforcing it's a jungle out there. There's lots of stuff happening. There's a lot of different systems that have evolved over a long period of time. There's any number of people. Of course, it's probably a kelp jungle, possibly with sharks in it, and definitely turtles, as in the ditto turtle. So how are we going to make some sense of this environment? Well, one way of dealing with this is to understand how the different layers of this can be turned into different levels of specification. And this is the sort of a typical pattern we've observed is we have pilots describing applications, digital twins describing our systems. Then we have the cross-domain patterns at the bottom left, so the Oceans Information Model core. And then we've got ways of implementing these. And this is where the OGC building blocks, the OGC APIs. So these provide the generic software support. The digital twins is basically where we set up the ability to talk to other digital twins. And the individual projects and the way we're testing these are through pilots, develop their own applications, their own transformations to related applications. So when we break it up like this, if we can make sure that those relationships between these are clear, then we can understand what the reusable opportunities, what the interoperability of any particular application, what its foundations are, what tools we can use with it, etc. So making that transparent is part of what we're trying to do. The way we're approaching this is we're exposing via the Oceans Information Model from multiple APIs. So if I click on this again, so we have a bunch of OGC APIs that we're setting up test cases for, that we deliver from various servers of different technologies from different sources of data. One of those pathways we're testing is also examples such as the pathways Raul was describing. We can basically bring them up to this this ocean information model through a technique we call semantic uplift. So typically we have data coming in a JSON data format, and we can use JSON-LD to tell us what each of the elements mean. What we do is we bind them to the web addresses of the elements of the Oceans Information Model. And then we can, once we've done that, we can test our ability to transform that to different forms. The resources to do this, I've mentioned, this is probably all the time I have. The OGC Rainbow is simply the linked data environment that provides the resources describing the models and the validation tools and these things. And then ultimately what we have is we have a series of tested building blocks which can be specialized. And just one final slide here. What this looks like in practice is the Oceans Information Model is we build a series of modular profiles. So we have one for the observations and measurements SOSA, which is a profile of both SOSA and the OGC Features API. So how do I implement SOSA in features? Well, that's my baseline. Well, what is Iliad going to do? Well, Iliad's going to have a number of specific rules around how we're going to do that with regards to the Ocean Information Model. For example, making sure that the observed properties are vocabularies defined using the standards, and SCOS was mentioned, which is a simple knowledge organization system. It's a way of describing vocabularies. But the Oceans Information Model will tell us what further constraints, and then we may have other reusable profiles, for example, for citizen science and for digital twins for talking to the biodiversity sector. And then finally, the pilot will basically inherit transparently all the constraints from these and define the control vocabularies which are specific to that application. And at the end of this process, this JSON-LD context linking to the JSON schema has mapped the Ocean Information Model at different layers to the APIs. And I can demonstrate this in more detail if time permits. We will be developing deep dives, and there's a bunch of links where you can go and see this stuff working. The GitHub repositories where we're performing the various tests for these things. But the takeaway message is that in this project, we will develop mappings to OAM from OGC APIs that are reusable. We'll provide examples of how they can be reused for your particular applications. And we'll provide the toolkits to allow you to build those specifications. And that'll allow you to use the OGC APIs in particular with the low cost and low risk. There'll be a complete specification that shows you how to use OAM with the OGC APIs that are available. OGC API features, Sensor Things API, the environmental data retrieval coverage one, and potentially there's some others as well. The toolkit we use can actually be used for other APIs. It doesn't have to be used for only the OGC ones. So again, you can use the patterns to work out how to map your other APIs into OAM as well. And that provides an extensible, open and transparent way of implementing OAM so that all your data services can share the same descriptions. So there's a bunch of links there, which are to the repository where we're working through the set of tested APIs, examples that we have for Iliad. Some of the baseline OGC API SOSA is one of the components. We're working on a thing called GeoGCAT for the OGC API records API. We have a register of building blocks. We have tools, open source tools. We have a template for building your own. And we'll be building in the Iliad and OGC Academy environments, resources to allow you to do that. It's still early days. We're very happy to take questions and constructive feedback and learn also how to do this better, because at this stage it has been an area where there has not been enough attention paid to mapping information models and APIs. Most APIs out there are depressingly ad hoc with very, very low levels of semantic interoperability. To do better, we have to do a fair bit of extra work. And just to give you a quick taste that this stuff is real, here's a link to the documentation generated automatically from the API, and we can sort of see we have a bunch of examples, and there's the JSON, and we can see it has things like we mentioned worms concepts, which could be URI, but we could also have, okay, there's a term.
Rob, if you're presenting, excuse me, Rob, if you are presenting something on the website, that's not something we can see.
Okay, so that was, let me, I'll do a new share, sorry. It should have been the whole screen, but let's go to this one. Thanks, Piotr. Sorry, we can now see. Sorry, I was just sharing the application. So this is just a sort of summary of all the resources in one of these profiles. So this is the top level profile for the Jellyfish pilot. It has examples as JSON, you can see over here, and little tools like you can view that in JSON viewers and so forth. JSON LD actually looks exactly the same, except for it links to the JSON LD description, which can be found here. So this is the JSON LD context, which is low-level technical detail. But the fun stuff happens that when we've turned this to the semantic version, what's happened is that all these things have been turned into URIs, and that can then click, and that can go off to a vocabulary server. This is part of the OGC Rainbow. So where we can register the vocabularies that are used in your application. So again, this is just very, very quickly showing you that the mechanism of linking the schema through to the implementation model, through to the control vocabularies, all those different layers can be integrated. It turns out this was not trivial to achieve, but we've now got a set of tools that do that, and we will now be testing it and providing reusable mappings for a suite of OGC APIs ready for use in Iliad and related activities. So I'll leave it there. Thank you very much. And there's an awful lot of detail, but there's some links there, and we're happy to take questions and feedback anytime.
Thank you so much, Rob. It's a lot to take in, but I think it's very valuable to see what work has been done and where you can interact. And you were, I think one of the key messages, Rob, is that you really would want people to test this out, right? This is important to improve and to develop further. That's
right. The mechanisms here are not are being tested out across a range of projects. This is a general capability, the OGC building blocks, and now I'm doing a much bigger project around cadastral survey, where we look at observations surveyors use, where and that incorporates provenance of the building blocks. So a lot of the same components that Raul has mentioned, we're testing out in other projects, other contexts as well. And that's the beauty of using standardized modules, as Raul mentioned, is the fact that we can test them in many different environments and make sure that quite a well-matured, tested thing can be done. and not trivial to do. So the more you can reuse the components, the easier it is. It's much easier to specialize something which is 90% there than it is to start from scratch. And that's the beauty of OAM and the modular building block approach to APIs.
Yes, so this is how we are actually doing this in a cost-effective way, as we promised to do in Iliad. So this is our approach. So thank you very much. Rob, can you unshare your screen, please?
Yes, I can do that.
So thank you. We we had a little bit of an experiment while you were speaking, because we had an open question for you in the chat. And what you can see is that we asked, what format and the APIs shall be supported by Ocean Information Model. So what is your wish, actually, dependent based on your experience and what your context is? We got 9 answers, so thank you very much for those answers. Unfortunately, I don't see them here, but when we come to the discussion, I would like you who answered to be prepared to take the floor when I give it to you, and let us know what it is. Thank you very much. And now, actually, we, as Rob, this is a good segue, I think, Rob, to you, Piotr, because Rob said it's important to have people test, to have people contributing to the further development of the Ocean Information Model and its implementation. And now Piotr will let us know about the options this can happen. But before that, I would like to introduce you to Piotr. Let me see. So Piotr is a leading and managing the ODC European COSI program, addressing initiatives in agriculture, marine, and building environment. He has also a long experience in other standardization work. He is contributing to Iliad with his background in standardization, and he has been both in commercial and multi-year experience in commercial software development, provision of Earth observations, telecommunication, and financial markets. So a wide range of topics. Piotr, the floor is yours. We are excited to hear.
Let's try to turn it on if I can share the screen.
Yes, you can now.
Hello, everybody. Yes, the idea was to think about this standardization perspective. We have some experience with this information models for different domains. It goes in different directions. So I started actually from trying to identify what could be these potential adoption areas in the standardization space, not even limiting to the standard itself, because we have these models that Raul presented on one hand, and some of them are simply the generic model that we align to, and naturally this itself component sub models could be will be handled and are handled by the working groups, by the owners, maintainers. There is this horizontal layer that could be potentially this added value to the model, and the linkages between this horizontal layer with the generic ones. Naturally, that has to encounter that there are already a number of vocabularies, ontologies existing in the marine space, and unlike some of the other segments, they are quite advanced, and these vocabularies are quite well adopted. Maybe not exactly in the same way, but the idea is actually the same. And naturally, we have this use case specific or pilot specific set of requirements for this ocean information model, which again could be like the submodels of the ocean information model. Then we need to consider who is actually the owner of that. And on the other hand, we have this integration of the APIs and the way that could be embedded in the data exchange or metadata exchange? How can we integrate the semantics into this let's say technical interoperability layer? The whole process of the entailment publication, well, you could be surprised how tricky can it be in the under the hood, and how tricky can it be to actually automatically generate the context information for the given payload. Even that you have a set of ontologies, the minimum profile is not always tricky, not always trivial, and the defining it could be tricky. And not really, there is a set of validation schemas that we are now helping to define for the pilots, but that probably shouldn't be the case for in general. Like the next iteration of these building blocks should be built together, and maybe in future there will be a community that will be able to define their own profiles of the standards. And in general, the standardization cycle, as we have it in well, this kind of bicycle we are driving, is actually between standardization and innovation. So there is the phase where we are in the innovation, actually. So we are doing research and trying to identify actually what could be the results that that could be adopted by the standardization bodies. Not even saying that it's OGC. It's quite common approach that we have that set of requirements we can go with to these working groups. And yeah, happy to hear also what kind of other working groups outside of geospatial information could be relevant for that, because as we mentioned, this is cross-domain. So I wonder if there's any potential update that I'm not aware of this ocean information model we can help, and we can try to divide it. Because having in mind that we are generating the results, actually this stakeholder consultation should be in every stage of that cycle, but naturally there is breakpoints that we need to come over. And the idea is that we are in liaison with several initiatives, like Rob mentioned, Turtle. Here could be these experimentation with some other communities that we don't have yet in OGC itself, but maybe we can try to see if that's if there's a potential for that cooperation in the future, because we need to. Am I showing? Yeah, we need to be clear that the standard itself, if that's going to be used, that's kind of product, and it has to be maintained. So it's both like a promise, commitment, and the value that we are trying to offer, and the commitment is from the community. That's why I guess there will be a question about the will to actually work on that in future, because the project is a project. It's going to an end, and then the standard is a living thing, and it has to be revised from time to time. And as we know, the domain-specific models needs to be maintained more agile, more lean, and the vocabularies must be maintained even more in more lean way. And that is going a little bit beyond the standardization, as we know from the OGC. But there are naturally the other options. So we can think about including that in standards, working on dedicated standard like ocean information model, let's call it. And but we can also and that's actually what we are considering now. If what we can do is already along the standards and compliant with the standards, maybe the option is also to provide kind of best practices or good practices documents or guidances, either on the formal level or on the academy level, Iliad Academy, whatever academy we can fill, because the process is then lighter, and naturally it still should be within the community, but we can do it easier. And coming back to the questions, what we can standardize, naturally, these 3 levels are potential candidates, as well as the way it can be structured. And considering the areas, I think that we should go fast now. So considering the areas and the standards that we can we have met in these experiments up to now, is that all of these let's say, elements of the metadata could be linked to the ocean information model, and actually should be linked to the ocean information model. So on all of this FAIR principle on the discovery level, naturally the dataset definition, the source of the data, either it's provided as the STA or any other representation, aggregated one. The source information about the sensor could be the same actually. That's linked to the values and to the space we are operating. And here again, there are the ontologies for the domain. The key aspect is to simply link it to the payload, and the structure itself is most complicated, but we are trying to simplify that in a way that it's more flattened. And yeah, I'm just giving so there's number of already standard that we are working on trying to provide these examples, actually, how this could be integrated. And here on the top, you see that there's still these legacy services. So the idea is that we are focused on the JSON representation as the new one. But for some of them, like WMS, WCS, will simply provide you the guidelines how to link to the ocean information model, at least on this basic concept of the properties and observer properties. But naturally, there are some areas that we are focused more. And Rob has mentioned the GeoDCAT review and the SOSA. So these are the working examples that he's already building, and this will go directly as proposition to the working groups. But there are also some new areas. So you may be aware that there is a new GeoZar working group that's going to be established. And actually, I think that it could be good area where we can try to see if that's something relevant for the metadata. Here, technologically, we are compliant because that's JSON, so we can simply propose the same context definition as we are proposing, for example, for the coverage is JSON. We don't know yet what will be the metadata conceptual model, but we expect that it will be compliant with the coverage information specification, which the other multi-dimensional representation are compliant, like NetCDF. ZAR to some extent, coverage JSON. Theoretically, it's possible, but not really. The challenge is now to make this ZAR specific to geo information. And as you even see in the objectives of the group, there's a number of requirements that they want to achieve, relying on the metadata information. And you may heard about the stack, which is very popular now. It's used by all around the new releases of the catalogs. So it was intended for the spatial temporal asset, like Earth observation data, purely. Now it's used for many things. So there's the core is very lean, and that's quite common in this recent approaches. That the core of the features API, records API, the stack API is quite lean and small, but there's a number of extension potentially. And that's also shared the idea between stack and the OGC API records. So as you can see, the OGC API records are expected to be a draft version beginning of the next year. And then the proposed approach is also to support the extensions. How it will work between the stack and the records is not yet agreed up to my knowledge, but the idea is that we will propose this approach of the building blocks for these profiles. It could be the added value to this stack specification already. So the stack specification is now defined. Well, the extensions are defined on the GitHub, but they are quite various. So not all of them are providing, for example, the schemas. Most of them are not providing any kind of semantic support. So if we are talking about turning data from one representation to the other through the semantic meaning, then it's quite a challenge. And yeah, naturally, the data spaces integration is quite hot in Europe. So Iliad is one of those that we have identified in the MOU with the IDSA that we can I mean, Iliad project is one of those that we have identified as synergies with the IDSA, and we'll try to use that as example, but it will be integrated with the other data spaces project, hopefully, and we need to find a common proposition between those so it can be leveraged even better. From my perspective, my feeling is that the discovery services and the catalog services would use directly building blocks as the extension of the generic catalogs with this geospatial capability, but that's my guess. And the data API will be more loosely coupled with this data spaces connector, while we still need to have the description of the data spaces about the specification in the data spaces. So yeah, then to summarize, because we are probably late and we should have time for discussion, because that's actually what we are trying to achieve here, also trying to socialize the idea of this domain model in here and within the working groups that we are talking. And naturally we are focusing on this several that we were talking from the beginning, like the observation and measurement that is planning to have this joint observation session in the next member meeting, with the covered JSON and EDR as one of those leading development within this MetOcean community globally. And that doesn't have to be limited to the JSON representation. Naturally, the NetCDF and ZAR are also supported by it, but the JSON gives you this nice sweet spot between machine readability and human readability. Then you can go in either direction. And yeah, that's then if there will be a will between the members, including the Iliad and not Iliad OGC members, another standardization group, we can try to also standardize the ocean information model itself as the standard. But that is probably the longest run, and that needs more people on board, and we need to agree upon that with some more communities. And that's my set of the ideas for the standardization. I'm not sure if it's clarifying anything, but at least hope make you think about that. Thank you.
Thank you very much, Piotr. Thank you for guiding us on how the community can contribute to the further process. I will show you, we asked a question, so the discussion will now start. So you will be able to ask questions and comment, and I strongly encourage you to do that. But first, I would like to show you the results of the last question, which was, are you interested in contributing to the further development of the ocean information model? Now you heard that this contribution might be done in steps, not directly but towards the ocean information model. But anyways, the result is here, and I think you should be happy with this. 81% is ready to contribute to the process, so that's a good sign. And then there are some 10% can be convinced. Thank you for participating in this poll. And now we are going to start the discussion. And before we do that, I would just like to congratulate all of you who have been involved in developing the ocean information model. I think this is a major achievement already from Iliad, and also a very good way for us to interact with the community around us. As you said, Piotr, there are many communities that can contribute to this, and I think to developing the ocean information models and the steps towards it. And I think this is a nice way for us to engage with this technical communities around Iliad. So congratulations to all. It's very impressive. I am excited to see all of this.